LED TVs are just LED backlit LCD TVs, that is, instead of fluorescent tube that is used to generate light behind the screen, LEDs are used, and this light, after passing through this LCD box, enter our eyes, which we perceive as an image. Now what happens inside this box? Light generated from LED firstly passes through a polarizer which polarizes it in vertical direction, and then through the horizontal polarizer. Now most of you will be wondering that there will be no light coming out of the horizontal polarizer, according to the Malice's law you studied in class 12 physics in CRT. Between these polarizers, there is a layer which contains liquid crystals which have the ability to rotate the light according to their orientation, and the extent of change in their orientation is controlled by applying a voltage across them. Therefore, the light passing after through the liquid crystal rotates by 90 degrees and then passes through the horizontal polarizer. And to see particular color filters are placed between crystals and horizontal polarizers, and therefore light coming through these filters is perceived as colored. Whole arrangement can be called a subpixel. Pixel contains 3 of these subpixels differing in their color filters with colors red, green and blue. And now the major role is played by a complex electric circuit which powers each subpixel's liquid crystal and altering its orientation, therefore altering the intensity of light emitted through each subpixel. An 8-bit per channel in the complex circuit can generate 256 possible intensities of each subpixel, and therefore theoretically generating 256 times 256 times 256 combinations of a pixel, and that's how we can see 16.77 million colors. And these thousands of pixels make an LED TV screen. Isn't that amazing?
In OLEDs, unlike LEDs, we can use any substrate to get light emissions. We use a thin transparent conducting layer of indium tin oxide formed on glass as a transparent conducting substrate. On the substrate, we stack very thin layers of organic polymers, an emission layer which is electron rich and a conducting layer which is rich with holes. When a voltage is applied across the emission layer, electrons absorb energy, and when they meet with the conducting layer and combine with holes, they give off their entire energy as photons, which we see as visible light. The brightness depends on the voltage applied across the emission layer. The different colors are got by having different band gaps between the emission layer and the conducting layer. In screens, every pixel is subdivided into 3 subpixels, red, blue and green. All colors are gotten by a combination of different brightnesses of these 3 subpixels. The different voltages to each subpixel are managed by a network of transistors. As screens made with OLED technology are so thin, they can be made flexible or even transparent depending upon the requirement. This is what allows for gadgets like curved screens and Google Glass to exist.
This is Aditya and
this is Daksh.
thanks for watching the video.